Good morning. Today we're going to be starting with chapter 6.8. You may notice there's a lot of commented code here. I pre-wrote the code to try to reduce the time of this recording lecture. You can pause at any time to see the code, and I've labeled, for example, here where the code is from. So you should be able to find it. Pause it, find it, look it up in the book. So we've done functions. We did the return. This is about returning a value from a function. So in order to return a value from a function, I'm going to go ahead and uncomment this part of the code. This is section 6.8, program 6.12. I'm also going back and forth between two different screens, so that's, if I pause, that's what it is. So we've had functions that don't return values. This is a function that does return a value. So this function, here's our prototype, sum int int. It's just going to be a program or a function that returns the sum of its two input parameters. So I'll start out with two numbers. I'll set them to 20. I have the total there, and here I call the function. So I'm passing it these two input parameters. Again, terminology is I pass them input parameters or input arguments. It calls this function sum. All sum does is return num1 plus num2. As I noted in the comments, this is a single line return. You can do that. Because we're not doing anything else with that sum in this function, we can just return it like this. You could also define a variable and use the following. Like you can do this. Int result equals num1 plus num2, return result. If functions are a little more complicated, this is a little bit better because then you might need to use result for something else inside the function besides just returning it. Or if a function is really busy and might look bad to read, expand it out also. But this is a very simple one. It does not ever hurt to make extra local variables. So it's just going to then come back here, put into total. Notice again, the names of the variables don't matter if you remember from class the other day. It is just the order that matters and that the types match. So if I run this, it's just going to say the sum of, I should need a space in front of it there, the sum of value 1, 20, and value 2, 40 is total 60. If you do not assign the output to a variable, nothing happens. Like if I do this, if I add this line here, and I call it but don't put it anywhere, it'll run, it'll do it, but total, or rather the return parameter, sum here, doesn't go anywhere, or what's returned here doesn't go anywhere. So if it has a return parameter, you have to make sure to assign it. Okay. Let me go ahead and recomment this. Okay. So again, this is nothing really new from MATLAB, just the formatting difference. So let's look at one more example. This is 6.8, program 613. We've got two functions here. GetRadius and square. GetRadius has no input. It outputs a double. Square inputs a double and outputs a double. GetRadius, we'll look at our functions first. No input. We're going to use we're going to ask the user for the radius of the circle and return that. So all GetRadius is just asking the user for a value. And sometimes functions are useful for that, especially if you're writing a big program where you have to ask the same question more than once. You may as well make it a function. And square is pretty simple. It's just a calculation. Again, it's a function because if it's a larger program and it's done multiple times, then you want to do that. So this is just going to also const double pi 3.14159. Radius and area doubles. This line here, just you need IOminute for that. That makes it so the output's rounded to 2 decimal places since we are multiplying by pi. Calculates the area of a circle. Get radius. Asks the user for a radius, puts it in variable radius. Calculates the area using that square function that we made. Now remember, C++ has that built-in function for raising something to a power, but we made a square function for that. See out the area of the circle is that. So I can say program calculates the area of a circle, the radius 5. The area is 78.75. Radius 10. Area is 314.16. Okay. Let me recomment this. There we go. So that's it about returning values from functions. It's similar to MATLAB, just that's the formatting. Very often, this is again a thing you may have seen from MATLAB. You might want to return a value that is a Boolean. True or false. Remember that true and false are built in to C++. You can see here it's highlighted in blue in this particular compiler. Back when I first started learning programming, we had to do we would do constants and say at the top constant int true equals 1, constant int false equals 0. But true and false are built into C++ now. So we're just going to make a function here. Enter a number and I'll tell you if it's even or odd. I made a function called isEven. It's very common programming practice. Again, this is just programming style. That if something checks something, if a function checks something and returns true or false for it, is and then descriptive, so you can look at this. You can look at the function isEven without looking at the comments or anything else, and you can guess this probably says whether it is even or not. So just the name of it helps with that. So isEven. If number mod 2 is equal to 0, don't forget the double equals for comparators. It's even if there's no remainder when divided by 2. Then status is true, else status is false, return status. You could technically write return true, return false there, but I'd rather set a variable and return it that way, just in case you want to do anything else in this function. And if it returns a true, then you'll write it's even. If not, you'll write it's odd. So enter an integer, 7. It's odd. Enter an integer, 12. It's even. Again, you have the code. If you want to look more on the flow of the program, you can put cout statements here. Like just for example, cout in is even true. If I do that, I need braces, of course, because I'm doing more than one line. Else braces. Cout in is even false. So I could do that. 6. It says in is even true. 7. In is even false. That kind of thing is useful for debugging. So extra cout statements like that are your friend for debugging. If something ever goes wrong or you need to check on something, that's the best way to do it. Making myself a note here. Okay. Oh, and then this was 6.9 program 615. Okay. Let me recomment this out. Next, we're going to go into section 6.10, local and global variables. 6.10, program 616. So, by default, variables are local. That means that a variable in main only exists in main. The functions cannot see it. The function can only see what gets passed to it. If a variable is in a function, main can't see it. Main can only see from a function what gets returned to it. So in this particular case, this program shows variables defined inside a function are hidden from other functions. So in main, well, here's another function, generic function name. Int num equals 1. In main, num is num. Call another function, same variable name, and we'll print it here. And then come back and see that it's unchanged. If I run it, in main, num is 1. Call the function, num equals 20. In that function, num is 20 right here. Back in main, num is still 1 because it doesn't matter that it has the same name, they're local. Which means that main cannot see what happens inside another function. Another function has no input parameters and no output parameters. Anything that happens inside another function is only visible in another function. Oh, there we go. Okay, comment that code out. 6.10, program 617. So now let's talk about global variables. Right here, notice the difference. Up here, I defined num inside main. Here, I'm defining num outside of main, up with the function prototypes. If it's defined outside of main, this is a global variable, which means that everything in the program can see this. And anytime this is changed, it's changed everywhere. So this is the same code here. In main, or similar code, in main num is whatever. Call another function. At the beginning of another function, it's the same. It should be 2 again. Set num equal to 50. Now num is changed to 50. Because num is global, and I changed it here, it's global, which means it should change back here too. So you can see in main num is 2. Then it calls another function. Num is 2. Right here. Now we set num equal to 50. And now num is 50. Num is 50. Go back. Because it is global, back in main, num is 50. You want to use global variables sparingly. Because if you make a variable global, it is very easy to make a mistake. So you want to be very sparing with global variables. In most cases, it is better to make variables local and pass them as input and output parameters to functions and back. There's also another method which we will go over. Let me look at my notes here. I think next time. I think it's next time. But only use globals sparingly. Okay. Next section. Oh, just so you know, in section 610 it says why global variables make debugging difficult. Any statement in a program can change the value of a global variable. So if the wrong value is in a global variable and it's global, it's harder to track down where it was set wrong. Functions that use global variables usually depend on those variables. So the function will not work in another program, whereas if it uses only locals, you can copy paste the function to another program and it should work. Global variables make a program hard to understand because it can be modified by anything. So global variables should be used very sparingly. It's better to make locals. Now, Constants. I didn't copy the program for this. Program 619 has some constants. It is common to make global constants. For example, pi. If you're going to use pi in your code, it is very common to do a constant global, a global constant pi, and you can do that just by declaring the constant. Where's the one I did earlier that had pi in it? Which area? Okay, so right here, constant double pi. If I put this outside of main up here instead, that would make pi a global constant, which is actually useful because pi is not going to change, and pi can potentially be used in lots of different things. So, especially things like that, if you're doing anything with science or math that has a defined value like pi or Planck's constant or something like that, uh, you might want to make those a global constant. The other useful thing is the example in the book is about pay rate. You might want to make that a global constant so that you only have to change it in one place. So global constants are okay because they're not going to change. Global variables you have to be careful of. Okay, let's see. Back to 611. Oh, we saw earlier. I didn't make the program for this. That if where did I say this? I want to make sure. If you happen to have local and global with the same name. The example was program 620. In 6.10, I didn't copy this over just for the concept. If you have a local and global with the same name, the local one takes precedence. I believe that's what it is. Yeah, local one takes precedence over the global. Generally, you should try to avoid making them with the same name, though. Okay. And the last topic for this video, section 6.11, static local variables. Static local variable is normally when you call a function. Oh, let me undo that. Normally when you call a function and the function is over, the local variables are not remembered. So, but if you want local variables to be remembered, you can do static. So I'm going to run this first before I explain it. And you can look down here for what it's doing. So I made a function called showStatic. This is a for loop. Count equals 0, count less than 5, count plus plus, just so that it does this 5 times. And you can see it does it 1, 2, 3, 4, 5 times. This calls showStatic 5 times. ShowStatic defines a variable static num is 10 and normal num is 10. Static num is a static int. So let's see what that means, because we're outputting the value of static num and the value of normal num. At the end of every time we call it, we add 1 to each. If it's a regular variable, it doesn't matter what you do to it. Whenever you call the function again, it does not remember what it was before. So you can see normal num. The beginning of the function sets it to 10. Right here, normal num is 11. Next time we call it, though, normal num is set to 10 again. And then it's printed, and now it's 11, but it doesn't matter. It's 11 because the function ends. Every time we call it, it's 10 again. If you make a static int like this, though, a static variable, it remembers the value each time, and it only makes this assignment the first time it calls the function. So what happens is it calls this function, static num is set to 10, right here. Now it's 11. Next time we call the function, because this was static and it had a value, it's going to say this has a value already. I'm going to keep the value at 11. So it prints 11, adds 1 to it. Next time, static has a value, and it's 12. Print it, add 1 to it, now it's 13. Next time, print 13, add 1 to it, now it's 14. Print 14, add 1 to it. It's now 15, but it doesn't matter because we're not calling it again. If we were to, outside this for loop, call it again, it's just going to do it one more time. 15 and 10. So that is the use of static variables in general. Static local variables are not destroyed when the function ends. Normally when a function ends, its local variables just go away. If it is a static local variable, it does not. Other things to note, if you do not predefine it like this, like if I just say that, static variables have a default value of 0. Regular integers have a default value of not 0. That mess. See, in this case, it messes up because we don't define it. But static integers have a default of 0. If you don't set it to something, the first time it's called, it's set to 0. If you do set it to something, that is its default. Okay. That is the end of that segment. And I want you to try to watch this as you can. Go back over the code as you have to, and just keep an eye for other announcements. Thanks.